Okay, so let's continue from the last video with two more trig functions of unusual angles. My cat induced me to accidentally stop recording, so here's a new video. So I want to do number 3 now. For another angle theta, we have tan theta equals 3, and we know that theta is in quadrant 3. What is secant theta? Okay, so the clues that we're given about theta are tan theta equals 3. I'm not sure if you guys can hear my cat purring, but it's pretty loud. This is in Q3, and I want to know secant theta. Okay, so I'm going to use a trig identity, and I want to find a trig identity that relates secant and tangent of the same angle. So these are not going to be much help unless I divide them or do like 1 over them. Let me see, here's one that has tangent and secant together and nothing else except for the 1. So that's the one I'm going to use. So this says tan square theta plus 1 equals secant squared theta. Okay, so I guess I'm just going to go ahead and I'm going to plug in. Remember, this notation really means tangent theta squared, and this notation really means secant theta squared in parentheses. So I'm going to go ahead and plug in 3 where tangent theta was, and then I'm just going to try to solve for secant theta. So on the left side here, 3 squared is 9, plus 1 is 10. I just had a bad feeling, like maybe when I went over this in class I said that was 4. If I did that, I'm sorry. Okay, and then to solve for secant theta, we just need to square root both sides. Remember, when you square root in a solution process, you need to put a plus minus because either positive or negative version of that would satisfy the original equation. Now, which one should it actually be? Remember, secant is 1 over cosine, and in quadrant 3, so quadrant 3 is down here, cosine is going to be negative down there because it's the x value. So I think I actually want the negative version here, and that is going to be my secant. Okay, let's do number 4 to finish up. Use a trig identity to find sine of 165 degrees. And the hint here is that 165 is 135 plus 30. So we really want sine of 135 plus 30. Alright, so I'm going to use an addition formula for the sine of a sum of 2 angles. It's this one. So for S, I'm going to put in 135, and for T, I'm going to put in 30. So I just need to fill in the right-hand side of this formula, and hopefully then I can calculate it. So this is going to be sine of 135, and then cosine of, that's going to be T, so that'll be 30. And then plus cosine of S, so that's 135, and then sine of T, so that's 30. Okay, and then I'm trying to find an exact value for this, so I want my unit circle values. So if you don't have those memorized, then you need a unit circle with you. Okay, so sine of 135, that is, so 90 is here. 45 is the halfway, and if I go another 45 over here, 45 plus 90 is 135. Okay, so it's one of these halfway into the quadrant angles. So the coordinates here, the cosine is going to be negative square root of 2, and the sine is going to be positive square root of 2 over 2. Okay, so this is negative square root of 2 over 2. Alright, and then for sine of 30 degrees, that is this one. So for the ones that are not the like halfway angles, it's the coordinates are either 1/2 and square root of 3 over 2, or square root of 3 over 2 and 1/2. Sometimes I just look at this and I'm like, oh, the y is the smaller one here, so that must be the one that's 1/2. Okay, so this sine is going to be 1/2, and then the cosine is going to be the larger one, square root of 3 over 2. That's just a little insight into how I have these memorized. Okay, and now we can simplify this. Yeah, so I'm just going to do top times top over bottom times bottom. So this is square root of 6 over 4 minus square root of 2 over 4. And I could combine that into one fraction if I want. You cannot subtract the 6 minus the 2. They're like, the 6 is locked in its own little box, the 2 is locked in its own little box. We cannot combine them with subtraction. So that's it. And I'll see you in another video.